say you have an LLM generate some code, right? And you want to execute that code in a secure manner, right? You could execute that within WebAssembly, right? So like a Python runtime compiled to WebAssembly, it's just way more secure than a VM, a container, and it's way more lightweight.
Hello and welcome. I'm Richard Simon. I am Cloud Therapist. WASM or WebAssembly, that's the topic for this particular video. I've kind of been really skirting around this topic a few times on the channel. You may have seen me or heard me talking about it in the past, but I've never really kind of gone into the detail. Well, now I'm actually ready to remedy that situation. So I want to give an intro in this particular talk to WebAssembly. So we're going to be doing like a WASM intro. And, we want to kind of really understand what it is, some of the concepts around it, where is it kind of going and how it's kind of, evolved. And how can we maybe do things like, deploying WebAssembly, some of the use cases perhaps, and why should we be, looking at WebAssembly at all? So Samy is the guy who is going to take us through all of that. I'll let Samy do an intro to himself, and then we can begin the talk. So Samy, go ahead.
Howdy, this is Samy Fodil. I am the founder and CEO of Taubyte. What we do at Taubyte is trying to close the gap between software development and cloud computing. So basically, when you look out there, there is that gap where there are the people that write software and there are the people that take care of the infrastructure. And sometimes, there are great tools that makes infrastructure as code as well, but it's still not developer friendly. So what we're trying to do is really put the developer in the pilot seat so they can do it all. And it's simple and sweet. And along the way, helping with like improving cloud ownership, helping with repatriation. And in the midst of all of that, we use a lot of WebAssembly. And this is what I'm here to, talk about.
Fantastic. Okay, well, welcome to the channel, Samy. I appreciate you taking the time to do this intro talk with me about WebAssembly. So let's kind of just kick off on the let's get to sort of understand WebAssembly. What is WebAssembly?
Yeah, so at the core of it, it's a binary format for executables. If you ever, looked into Java, Java code is compiled to binary code that's executed by the JVM. So it's the same thing for WASM, except that it's not limited to one programming language. So multiple languages can, be compiled to WebAssembly, and then that format, which is WASM, can be executed can be executed in different platforms and different contexts, and that's what makes WebAssembly powerful.
Right. Yeah. So it's kind of, I guess, would you say it's sort of delivering on the old sort of Java promise of kind of write once, run anywhere sort of approach? WebAssembly is actually really doing it for real.
Yeah. Without the constraint of limiting you to one programming language.
Yeah.
And also like one set of kind of like host APIs if you wish, because with WebAssembly, that set of host APIs is not predefined.
Right. Yeah. So it's kind of a couple of advantages there, I guess. That kind of, write once, run anywhere, as we said, but also the language that you're writing in doesn't have to be Java. It can be, Python or whatever else you've got that you're.
Yeah, exactly. This is why you'll find and then maybe we'll get like more into more details during the chat here. But
Mm.
you'll find WebAssembly used in web browser, let's
Hmm.
say to accelerate processing.
Yeah.
You'll find it in authentication. So you can just compile code to WebAssembly, and then you
Mm.
will validate or do that. You'll find it in Web3, doing contracts because you can make it consistent and
Yeah.
predictable. And you can even generate proofs for WebAssembly. There,
Right.
there is a work around that. And then you'll find it in serverless in backend because, it's also, a great tool to do that. It's very fast to provision, and the start time is
Yeah.
is or the cold start is close to zero. So
Fantastic. Yeah. So I mean, obviously that's yet another advantage. We kind of mentioned size is kind of much smaller in terms of how it
yeah.
operates, and but also the cold start time is also yet another advantage as well. Okay. So how does it kind of really differ from what we've had before? We've kind of talked a little bit about it and kind of what how it operates, but then and we spoke about sort of you compile the code, it needs to be loaded. There's I think a kind of an instantiation step, which is kind of maybe setting up the the runtime environment and things like that for the code. And then you obviously execute the code, and presumably that can be your normal binary if you're kind of in that Unix and Unix-like environment like Linux and what have you, and then a .exe for for the Windows side of it. Okay, so is that runtime then being sort of attached to, or is it kind of put into the same file as the as the code itself?
No, so the runtime is separate.
Mm-hmm.
The module only generally only has your business logic, if we can call
Right.
that.
Yeah. Yeah.
So it will have those language specific runtime, right? Like if it's Go, you'll have that. If it's Rust, you'll have that, and
Right.
so on. But the real runtime is really on the host side,
Mm-hmm.
and I mean it could be anything
Yeah.
as long as it provides the host API that's
Mm.
required. So if it's WASI has to be there. If
Mm-hmm.
it's some specific interface, it has to be there, right? And that's mainly it.
Okay. And was is the just to kind of clarify it for our audience, that's the is that the API side of WebAssembly?
WASI is a, an effort to make it possible to build most regular code
Okay.
into WebAssembly. So it has some POSIX similarities. So
Mm-hmm.
it's kind of like compatible, but we don't want it to be 100% WASI or
Okay.
POSIX,
Right.
right? So it's like not everything will compile to WASI, but most would, if it
Right.
makes sense.
Okay.
Yeah.
Okay. Yeah. So I picked up. I had a look at the WebAssembly website. So I'll provide links to all of this, by the way, in the description of the video for the audience. But it said on there, and I kind of always like to see what the official definition is for something. So it said WebAssembly, or abbreviated as WASM, is a binary instruction format for a stack-based virtual machine. WASM is designed as a portable compilation target for programming languages, enabling deployment on the web for client and server applications. So, yeah, I guess that kind of makes sense. It may be a little bit convoluted in the way that it's kind of being described, but what do you think of that definition, Samy?
I mean, I think it's pretty accurate. I mean, it is maybe a boring definition, but it's
Yeah,
accurately. You take code, you
yeah.
compile it to WebAssembly, it generates a module, and that goes into like a VM, or call it like a
Mm,
virtual CPU that
mhm.
that executes that code.
Yeah.
What's cool about WebAssembly, and maybe well, it's not yet there. Maybe in that definition is, you can load multiple modules in on like within the context of the same runtime and make them talk to each other. So one module could be written in C, the other in Go, the other in Rust, and they can all
Okay.
interoperate.
Sure. So that and yeah, and the modules is the actual code. That's what we mean by modules in this context, right? That's kind of the
Yeah,
code
it's
that
the
you've written.
code. It has its own memory,
Yeah.
and so on.
Okay,
Yeah.
cool. Now, the other question I had, just curious, and I didn't get around to finding out the answers, is I'm not sort of an expert on WASM. If you let's say all your code is in Python, okay, so we've got lots of modules that are all in Python. Can we run all of, just like we do the container runtime, can we run them off of one WASM runtime? So rather than each of those modules having its own sort of WASM runtime, can they all sort of be pointing to the same one?
Okay, if you write your code in Python, you're kind of like in trouble with WebAssembly. But
Okay. Oops.
uh, well, I mean, there is an effort out there that ports like Python into a WASM module, and
Okay.
then it will run your code. But each module is separate, and then it's really up to you on how you want to use that. So you can
Okay.
have one runtime having multiple modules if you want them to communicate between each other. If you want more isolation, you can have one instance of the runtime
Okay.
just running one module, which is the case in like if you run in serverless, that's mostly what happens. Like there is an
Right.
instance of the runtime and
Yeah.
then an instance of that module, and it runs like that. It's secure and it's still efficient. So
Okay. And so essentially it's kind of flexibility in terms of how you want to do it and how you want to carve the environment, whether, as you said, you want isolation, multi-tenancy maybe, or whatever, that type of thing. Then I guess that's kind of up to you. Okay.
yeah.
Cool. All right. Now I'm not sure whether I had anything else on that. Oh yeah. So the other thing was, so the, as we said, the compilation side is kind of where the language, so C, C++, Rust, Python, whatever it is that you're doing, that kind of compiles it into the so-called WebAssembly bytecode, I think. And then,
Yeah.
but from there on, the next few steps, the next sort of 3 steps, which is loading, instantiation, and the execution, that's where the runtime, the WASM runtime takes care of that. Is that correct? So it's kind of the, you're now running it on the target system, basically, right?
Yeah, exactly. So
Right.
like starting from your code, you have different steps. I mean,
Yeah.
it's straightforward with Rust and Go,
Mm.
and Zig and languages like that.
Yeah.
Not as straightforward with C, for example. But
Right.
yeah, you compile your code to WebAssembly that generates a WASM file. And then from there you can just use it directly, especially if you're profile and debugging
Yeah.
whatnot. And if you're going production, you can do more optimization. So you can optimize your code. You could do some pre-initialization with Wiser. It's a little tool that basically pre-initialize your WASM code, so it's
Okay.
saves time. Depending on the system you're running in, you could do some ahead of time compilation if you're sure, like, hey, this is my target and
Yeah.
whatnot. Most runtimes will have that option. So the first time you load a module, they'll compile it and put it in cache. Like WAS0 does that, for example. If they're doing ahead of time, compilation, basically turning it into machine code, right? So it's faster and native
Yeah.
speed. And some can do just in time. So V8 can do just in time, and will just do that in time.
Okay. Cool.
Yeah.
So I know WASM kind of started life in web browsers, interestingly enough,
Yeah.
but it's no longer that, right? It's now standalone. Is that right?
Yeah, so it started in browser. The idea there is creating something that's faster than JavaScript.
Yeah.
Less heavy as well. And then it made its way to other use cases. I mean, I mentioned a few at the beginning, and serverless compute or backend is a very good one.
Yeah. Yeah. Cool. All right. Okay. And I mean, the whole idea, I think, that we're sort of heading to with things like WebAssembly is essentially having that, next or even smaller unit of computing, right? So we can, and by that I mean kind of, running some code that will do something for us, right? And WebAssembly holds the promise of making that unit of computing even smaller than what we've kind of necessarily been doing prior to that, with things like maybe, breaking up a monolithic application into smaller components, or, doing things like microservices, and, really kind of doing it in a service mesh and so on. But would you say there's a clear distinction between kind of an app or a workload running in microservices? Yes, I mean, they're all containerized, they're all orchestrated with Kubernetes and what have you. So the vessel is essentially the same, but the code and the way that we've kind of we're developing it with WASM is smaller. Is that kind of counting as the smaller, delivering that smaller unit of computing? Would you agree with that?
Yes, definitely. So the unit of compute is generally smaller. Bigger WASM file tend to have issues with loading them, actually, because you have to load that code and create the context. It's generally faster with good runtimes, like WASM time was 0. I mean, they'll optimize for that, um, but yes, the idea is to really have smaller files,
Yeah.
And then they're faster to load, and it's very easy to execute them. So you have that advantage of an interpreted language, like all that isolation abstractions, without the performance drawbacks,
Right.
and the dependencies, kind of like, I don't know, if you're writing some code in JavaScript, you might just, even if it's a little bit of code, you might still ship a lot of JavaScript code with it. Same with Python. With WebAssembly, it's really that code that you wrote.
Okay, right, cool. Okay,
Yeah.
So it kind of gives us that opportunity to run something a little bit lighter than sort of what we're used to at the moment. Whatever we put into containers right now. Okay, so let's kind of move on to sort of the deployment process. Now we were just talking about using containers and orchestration, but is there like a WASM orchestrator, something that's kind of dedicated to that WASM space?
Okay, so there are two parts here, like the deployment and then the execution, right, or the orchestration of the code, right. And sometimes they could be a little bit intertwined there. So deploying your WebAssembly modules really depends on where and how you're using it. There isn't like really one way to do it, right? So I mean, for example, if you're doing it, on the front end, you might look at some tools out there. Like I think Webpack has some tools, and some other frameworks have tools that facilitate that as well. If you're doing it on the back end, it really depends. Like how are you going to use your WASM file, right? So you can there is a way to ship WASM files in OCI containers. You can also ship your WASM file with the runtime. Like you can have your WASM file and WASM time, and then just run it together. Or others, like there are other like runtimes out there that have like HTTP endpoints and stuff like that, and they'll do some orchestration, right? Like if they have, like, generally each request will spin up an instance of the module, and that goes to the fact that right now, memory management when it comes to WebAssembly is not the best, right? So like it generally just grows, and you don't want to keep that module live in there. It's also good for security, but run it once and then discard it, start another runtime with a new module. Um, uh, and then there are other ways, like for example, we built some tools. So with Tau, it's pretty easy. Uh, Tau has a CI/CD included with it, so you just focus on your code,
Okay.
and it's almost that made so you don't even notice that it's WebAssembly, right?
Right.
So you just push your code and then you'll compile it to WebAssembly for you. Go and Rust and assembly. So it's more complicated for other languages, so we
Yeah.
didn't do that yet. And then you will create a WASM file. Now, how you deploy it is different, right? Like you could use OCI, so it's in a container. The way we do it is we use content addressing, so that WASM file is scattered across the network
Right.
in a peer-to-peer manner, and then we address it with its hash. You can cache it that way. So it's CDN native, and you can grab these little modules pretty fast. You can also publish your WASM file, to a web server
Mm.
and whatnot. Like if you look at NPM modules that are using WebAssembly, you'll see that in the package there is a WASM file. That's basically it.
Okay. Right.
Yeah.
Okay. Okay. And so really kind of we just kind of touched on sort of a smaller unit of computing and sort of smaller code and things like that. So I know that people have talked about edge and IoT as well. So
Yeah.
I'm presuming that kind of this whole WASM ecosystem lends itself towards those types of use cases as well. Is that correct?
Yeah. So for Edge, WASM is perfect because just go back. Even if you're not doing content addressing,
Mm.
it's very easy to hash that
Mm.
WASM module and cache it.
Mm.
For IoT, um, it's a great tool because it's easy to update your code if it's WASM. So your runtime, the host functions that you're providing
Mm-hmm.
are kind of like the same, and then you're just updating that WASM code, which is portable, right? So as long as you
Right.
have the same host functions, because that with IoT there is a lot of different hardware managing different version of the hardware, but if the runtime is persistent, you just need to push that WASM module, and it's hardware independent
Yeah.
and platform independent. So over the air updates, stuff like that, it's just perfect for the use case.
Right. So we're kind of wondering what they were doing before WASM came along then on IoT. Okay, excellent. So I've also heard of something called WASM Cloud. Is that kind of, would you say that's kind of a standard orchestrator for for the WASM space?
So when you go to orchestrate in WASM, there are a lot of ways to go around it.
Mm-hmm.
WASM Cloud is one way.
Mm-hmm.
What we've built, Tau is another way. The
Mm-hmm.
Tau is more kind of like a platform as well, so it has its own CI/CD,
Cool.
storage, key value stores,
Yeah.
messaging pops up, stuff like that. WASM Cloud, I think they use NATs to propagate messages,
Ah, okay.
and you have to set up that, and
Mm.
there is still some ops to be done there. But yeah, WASM like Cloud is one way, and then there are other ways that you can use to orchestrate your WASM load.
Okay.
Yeah, for sure.
Okay. So what would be kind of, if we sort of looking at sort of best practices for packaging and distributing the WASM modules, is there any sort of top 3 things to maybe do? What's your opinion on that?
I mean, I don't think there is a really like one way to do it right now. I think the component model is kind of trying to solve that.
Mm.
Um, I'm not sure where it's going to go
Yeah.
yet because the support right now is limited to WASM time as a runtime,
Right. Okay.
and that kind of like limits who can use it.
Yeah.
There is a from my point of view, kind of critical a little bit about that. Like
Yeah.
there is some reinventing the wheel there.
Hmm.
Like, why not just using, for
Mm.
example, proto buffer
Yeah.
instead of reinventing the wheel
Right.
and having like the width that defines, it's basically like a file that defines what the WebAssembly file exports.
Yeah.
And the other criticism is you have to that's not embedded in the WASM file itself. So you have to carry that width file
Yeah.
around with the WASM file as well.
Yeah.
Um,
And
but yeah,
Sammy,
I mean, there isn't one way,
yeah,
unfortunately.
sorry to interrupt, but I was just going to ask, because you were saying that, is that because people just have different opinions on how to do it, and people have just kind of, come up with different ways of doing it? What's kind of behind that?
I mean, the idea of WebAssembly is to not define an interface, right? So
Mm.
WebAssembly itself,
Yeah.
like it's in its raw format,
Yeah.
you can run it without any host function or API, right?
Hmm.
And then it goes from there. So WASI provides that kind of POSIX compatible, so you
The
can open
interface. Yeah.
files and do things like that, like print, text on your console, stuff like
Hmm.
that.
Yeah.
And then the component module is like, okay, like we can say that this module provides this interface.
Yeah.
You can read the interface of a WASM file, see what functions it provides. However, there are basic types that WebAssembly supports. So float,
Mm.
ints. Um, I mean, uh, that's mainly it, right? And the problem there is, how do you deal with complex data types?
Right. Okay.
Right. So in Tau, we deal with it in different ways.
Hmm.
Like, our way is try to minimize data transfer between the host and the module.
Okay.
Um, there are other ways, like, for example, XTISM, which is an amazing kind of framework where you can, include like other packages you build in other languages, compile them to WebAssembly, and then run them into whatever language you're using. Could even be Python. Um, and they provide basic types, so you can pass in strings and bytes and stuff like that, and they pass it in memory at the beginning of the execution. And then I went through that just to kind of like simplify what uh, the component model is about, right?
Yeah.
So
Yeah.
so the basic thing that it's solving, it's basically encoding and decoding data between the host and the module and different modules,
Hmm.
right?
Yeah.
And the reason is, different architectures encode things differently, like numbers, for example,
Yeah.
but also different languages encode structs, right? For example, differently. If
Mm.
I take a struct with a Ghost struct and try to pass it to C, it's not the same.
Right.
So if you want perfect interoperability, you need an encoder decoder between, these modules, including the host itself.
Right.
And that's
Right.
what the component model tried to do.
Okay, cool. Now, I know you did a presentation, I think back in May. It's up on slideshare.net, which was WebAssembly is key for better LLM performance. So again, I'll
Yeah.
provide some information on that. That was a really cool one. I went through the slides on that. So that was quite interesting. That was kind of really trying to what was it, sort of bridging the gap between sort of WebAssembly and LLMs. What was the gist of what you were trying to achieve? That just kind of the audience knows what the idea was behind the presentation.
Yeah, for sure. So there are two layers to that. So the first one is knowing what LLM or what functions the module is going to use. So, and you can know that if you just read the headers. I'm just calling them the headers, right? But in the WASM file, so there is a section that defines that. So when you read that section, you can know what the module is trying to import. And you can use that in your gateway or load balancer to send the request to the right host, right? Like, you're keeping information like, oh, this host is running Llama 3, this other one is running, some other model already loaded in memory and all of that, right? So that's the first layer of optimization. The next layer is doing the inference, right? So generally, what's happening out there in general, you have the inference server, and Triton does that too. And then it takes your request, and then it goes through, the network and try to get to the right inference server, which could be in the same network, but um, it's still going through the network stack, right? With
Right.
WebAssembly, we can turn the inference into a host call. So basically, it's a WASM module, and then it just right there in the same host, it's going to the routines that's doing the inference,
Yeah.
runs the inference, and then returns the answer back. So we're cutting all that network stack and eliminating that latency, and that's kind of like the second kind of like improvement there in terms of performance.
Right.
Um, there is another advantage which will not improve performance,
Yeah.
but ensure that the request is handled, right? So let's
Okay.
say you get that request, it goes to a function. So your function is, let's say, an agent, right? So it's not
Hmm.
just doing one thing, right? You have
Yeah.
your logic there, and then you're hitting your inference engine to get your answer. So if the local server doesn't have it, it could also reroute it to another server. That's
Right.
something that could be built. For what's amazing is, for your WebAssembly code, all of that is transparent. It's
Hmm.
always just a host call. Like
Sure.
it's a function call. It could run locally. It could run on a different host. It could run any inference engine
Mm.
um, without you having to change your code. So your same
Right.
code you can run locally. Let's say hit Llama for development, right?
Hmm. Yeah.
Or Llama CPP or whatnot, and then you deploy that to the cloud, and now it's going to TensorRT or something else like an Onyx runtime. It doesn't really matter. Your code is the
Right.
same.
Okay. Interesting.
Yeah.
Okay. Cool. All right. Well, we'll certainly provide, like I said, details, and I've got the link to that. So check out the description. Hey, if you are enjoying the content, please don't forget to subscribe to the channel. That would really help me out. Thank you. Okay, so let's kind of look a little bit at some of the challenges then, Samy, because I'm kind of interested just to see where things, where we're kind of maybe hitting brick walls and obstacles that we need to get over. So what are kind of some of the maybe common challenges then that we might sort of face when we're really trying to do anything with WebAssembly? I mean, let's kind of say we're sort of, yeah, we tested it and we like it and we're kind of getting into it, we're really interested. Okay, now I want to kind of, deploy some stuff. And, how can I do that? How can I build that into this, massive infrastructure that I have in the cloud? And where's it kind of going to fit in with that? So what are the sort of some of the challenges? I don't know if they're kind of maybe security related or otherwise, but you tell me.
Yeah. Well, there are challenges with the question that, I mean, you ask actually, like how do I deploy it?
Yeah,
How do I build it? How do
yeah,
I deploy it? These
yeah.
are the first challenges, and this is why, like, you need a tool that can help you make that uh, efficient and as seamless and simple as possible,
Hmm.
right? And there are many tools out there. Well, not many, but there are tools out there, right? Like
Mm.
you can leverage. Um, and that's the first challenge. The second challenge is actually, debugging WebAssembly.
Mm.
So, and profiling WebAssembly. So there are little, like, some tools out there for profiling
Yeah.
that are amazing. Um, Debugging could be challenging sometimes because it really depends on your language. So some languages do not generate a lot of debugging, so you're
Mm.
you're not going to have like a very good debugging. A stack print is, it's not going to be something that's obvious, like, oh yeah, that's where my code is having issues. Um, and these are still kind of like the challenges, right? And
Yeah.
then bringing it into a whole, like, let's say you had an application and then you split it into WebAssembly modules, and then now you're testing the whole thing.
Right.
That will be like another challenge. It's not impossible to overcome, obviously. I mean, you can, build something just like you would do with a regular, containerized application,
Sure.
build a dev
Sure.
environment, for example.
Yeah.
We do it with something we call Dream, so you can set up a little cloud with all your project, and then you can do E2E tests on all of that with code. But and different environments have different ways. Observability is another thing where WebAssembly is still lacking. So it's not 100% there. But I think the journey is worth it because that like we're getting in, like the idea there is like more security, more portable code, and I mean ultimately just imagine uh like let's say you have an LLM, and I'm just going to LLMs here quickly. Let's say you have an LLM generate some code, right? And you want to execute that code in a secure manner, right? You could execute that within WebAssembly, right? So like a Python runtime compiled to WebAssembly, it's just way more secure than a VM, a container, and it's way more lightweight, right? So the cost of executing an LLM generated code on a Python a runtime compiled to WebAssembly is way cheaper, than spinning up a VM or a container to execute that code and get the result. And then the other one is kind of like a little bit maybe in the future is there is less risk to having AI generate code. Like imagine your code is now WebAssembly modules that are like very kind of like secure and just do one or two functions. Now you could have AI generate code and have that code compiled to WebAssembly. So if it compiles, that's one validation, and then you have your unit tests and whatnot. You can have the AI do that too, and then after that, even if the execution have a problem, it's a very contained execution environment. So you're not gonna have the security issues or security concerns as much, as a container or something else.
Sure. Okay. So in terms of just for the audience to kind of understand, when you said about debugging, are we talking about the code itself, or kind of it's sort of operating within that sort of WASM, environment? What was your kind of, where were you sort of leading with that?
Yeah, it's the code itself. So yeah, it's literally the code itself, like the stack prints that you have with the WebAssembly most of the time are not very meaningful. Depending on what language you're using too, but and sometimes it's challenging as well. There are considerations to also keep in mind, by the way. So like I'll give you an example, right? So you'll find yourself, let's say, with an issue if you don't pay attention to memory, right? So if like the max is 4 gigs, but if the runtime limits the memory, let's say, to 10 megs, and then you get like your WebAssembly module crashing, you need to keep that in mind. It's not going to tell you, oh, you hit the memory limit. And another example is if you're using, let's say you're writing Go, and then you're using channels, right? And your code, was compiled to to not have like a scheduler, right? That will crash as well, and it's not obvious that you'll know why, always. So these are things that makes it hard.
Okay, and just briefly on you mentioned profiling. What's this kind of, just for the audience so they kind of sort of understand what is profiling in this context? What did you mean by profiling?
Yeah, it's basically kind of like the same as profiling, any other code, like see what functions are using most CPUs, like what's using most memory, stuff like that, so you can, debug the bottlenecks or, improve your code.
Okay, and do the tools in that space, do they care that this is normal code that we're just going to run somewhere, or do they kind of care that this is, do they distinguish between WASM code versus kind of just normal conventional code, or do they just not care about that in terms of profiling?
Yeah, so if you're profiling a WASM module, you need a WASM profiler
Okay,
tool.
right.
I think one is WZ-Prof, is one of the tools out there that you can use. But like the good like a good way to do it in general, because even these tools, because of the lack of debugging information in the WASM module, you might still have some issues. It's always good to profile your code outside of WASM. So if you're using like Rust or Go, which are can compile to your platform's code, you could profile it that way, fix the issue, and then you can go to WebAssembly and then use some of these basic profiling tools.
Okay, I'm getting kind of the impression a little bit, and you kind of feel free to give me your opinion, that there's a lot of kind of, in order to do it in WASM, you need to these tools. In order to do something else, you need this kind of platform. There's like a number of specific tools that are sort of dedicated to that sort of WASM space. But do you see that maybe some of these will kind of get integrated into, maybe they are already, so you correct me, but do you kind of see some of these kind of being integrated into some of the more normal tools or standard conventional tools that we're already using? So things like in let's say in observability, can we see that sort of stuff in Dynatrace or Turbonomic or any of these other guys out there, Datadog and so on? Is that sort of where we're heading with some of these things? And are those kind of vendors you think are looking to integrate them, or are we still sort of, there's separated concerns so far?
Well, I mean, there might be efforts out there that I'm not aware of. But the cool thing about WebAssembly is, that isolation and the fact that you can do a lot on the host side that even the module is not aware of, right? So you can build a lot of observability into your runtime, right? So even if the module itself doesn't have it, the runtime will cover for that, right? And then you'll have like a lot of observability there because of that. So it can be like what I'm trying to say there, like the reason I'm saying like it's lacking observability and tools is it's still in development. It's not as WebAssembly is not as adopted as containers or Node.js for that matter, right? So there is still a lot of work to be done there, and there is a lot of because there are a lot of ways to solve the problem. I think the ecosystem is very diverse, and it might be challenging for people to jump in and say like, okay, where do I start?
Okay.
But once you get the hang of it, I mean, it's not necessarily as challenging as maybe early days of containers.
Right. Okay.
Yeah.
Okay, cool. Okay, what about sort of just touch on a little bit around the security aspect? Obviously, that's probably going to be quite high on people's agendas when it comes to maybe using, adopting
Yeah.
WASM. What's kind of the security like? How does that sort of work and contrast with containerized environments and orchestration and things like that?
Yeah, I mean, you can compare kind of like a WebAssembly runtime to maybe a VM. with less overhead, right? So you don't have the kernel, you don't have the hypervisor, all of that. So
Mhm.
it's even thinner than a Unix kernel running on a VM, right?
Right.
And as secure. Uh, in addition to that, you can do a lot more, right? You can you say like, hey, I'm not giving networking to this VM. Yeah, you can look into the basic calls,
Mm.
like networking calls or even file system calls. So I'll give you an example, right?
Mhm.
So let's talk about file system, right? So if you're running a container, you basically bind a real uh, folder from your system to the container, right? You
Right.
map it,
Yeah.
right? And
Yeah.
and it's that, right? It
Yeah.
goes through your kernel and all of that.
Yeah.
With WebAssembly, you can even provide a virtual file system, right? So that virtual file system could be in memory, could be across the network. It doesn't matter as long as you provide the basic, API calls to open a file,
Yeah.
see what's in a folder, and so on.
Yeah.
And you can secure it that way. So that's what's powerful. So you can, for example, if a function just needs to do very fast, like magic IOPS, very fast IOPS
Mm.
on some files. You can just give it a virtual file system that's in memory,
Yeah.
right?
Yeah.
And just limit the size. So like, okay, you have 10 megs or 100 megs in
Mhm.
memory, do all the IOPS you need, and that's it. And that's gonna be, faster than anything else. It's in memory, you discard it after, and it's not going to touch your real file system at any point in time.
Yeah. So that kind of maybe primitive approach, and using the word primitive literally, is kind of quite a primitive sort of way of doing things. It's stripped down, if you like. That's maybe adding that sort of advantage to it, that it's not open by default. It's actually extremely close. And we've kind of talked
Yeah,
about, in the past there's been conversations around sort of whether something like Kubernetes ought to be completely open or completely closed, kind of a zero trust sort of approach in the cloud. And we certainly kind of maybe default to that now, in the cloud. But actually WebAssembly is kind of maybe going even a step further. So, no, there's no file system. Just give me this space, create this space for me, create this environment or create these parameters. And that's all I need to, dump some temporary files or whatever it is I do,
yeah,
I need to do it. And it's, as you said, it's doing that. You can even do that in a virtual sort of file system in memory, right? We don't have to actually write out or map out to,
exactly.
to a hard
Yeah,
drive and, get to a SAN or get to a, S3 or bucket or whatever it is that we're trying to do, right?
exactly. You can even abstract it more. I had an interesting talk with a developer a few months ago.
Yeah.
He mentioned a system. I forgot the name of it. But and then going down the rabbit hole, we're like,
Mm.
okay, you know what? You can provide a WebAssembly module, a virtual file system that actually allows external calls, right? So, for example, if I want to kind of like call another module,
Yeah.
right, I could just write into a file. And on the back end, on the runtime
Yeah.
side, it's going to go and let's say reach out to a service or a database or
Mm.
anything like that, and then return the result of that as a read from a file.
Yeah.
So it's a powerful interface for sure.
Right. Excellent. Okay. All right. So let's move on to just kind of touching a little bit more around the sort of the observability and monitoring. Um, are there sort of any specific sort of tools, as I said, in that space that you would maybe recommend, or as I said, are we kind of going to be able to use our normal standard tools that we use for observability and diagnostics? Or I think you mention something around sort of specific tools in that space? Is that correct?
I did not.
Okay.
I mean, the best way to do it is to do some research.
Hmm.
Um, Most runtimes right now, like WebAssembly runtime, do offer networking. So a lot of the tools that you might use might just compile and work out of the
Oh,
box.
okay. Right.
And if that's not enough, and if you want even more, you can add to the runtime. If the
Right.
runtime doesn't have it,
Right.
you can definitely add to it,
Okay.
and have even more observability there.
Okay. So what are some of the sort of critical performance metrics that IT teams should be monitoring for, should be looking for when it comes to WASM applications?
Well, I mean, I think the execution of the code is not going to be as fast as native, but very
Mm,
close, because there is always a trade-off there between
mm,
portability and modularity and speed of execution.
sure.
But I think they should see, like, unless the modules are very heavy,
Mm,
or they take long to initialize,
mm,
in which case, tools like Wiser should be used,
mm,
to minimize that time. Uh, like, the cold start should be way, way lower than any container-based, serverless platform or solution.
yeah.
Um, the other thing is, it depends on how much or how many requests they're having, and
Mm,
how the orchestrator is handling that. Remember, I said, like, most of the time, you you need to throw that runtime, and
yeah.
like, after execution, and then
Yeah.
spin up another one. So you need to make sure whatever you're using can handle a high load of execution. Like, whether by kind of like getting instances ready to go. That's what we do in Tau. We call them shadow instances. So
Hmm.
you'll say, like, oh, there are a lot of instances coming, and then it will spin up, runtimes with the module, and they're just lined up there for execution. Um, and again, that's also a trade-off, right?
Hmm.
Like, you're using more memory.
Yeah.
I mean, obviously, but you're gaining security and portability doing that. So.
Okay. And I assume there's like a way to sort of maybe optimize the performance, of the WASM modules for different environments. Does it kind of matter if I'm doing it in maybe Python versus Rust or Go or something like that? Is there kind of, you mentioned kind of trade-offs and things like that. In other words, is there a lot of that you have to do? People have to really, as you said, sort of go down those rabbit holes, or is a lot of that maybe taken care of for you? What's your take on that?
Yeah, I mean, yeah, you could automate a lot of that. Like, we build a lot of that in Tau, so it will optimize your code and do a
Mm,
lot of that for you. So you really focus on writing your code.
mm,
But again, like, it depends. It depends on what you're doing.
mm,
I think. Um, I mean, in general, like, what I'm saying, like, trade-offs, it's mainly uh, a few things. Number one, like I said, most of the time you need to dispose of the module after the call in the case
right.
of serverless.
Hmm.
So that's one thing to keep in mind. The other thing is, there isn't a good support for threads right now. So
Right.
it's a single thread. And that's, like, the other trade-off. It doesn't have to be a trade-off. It really depends on your use case. Like, most of the case in serverless functions, they don't really need to do more than, one thread. But
Mm,
you just need to keep that in mind.
right. Cool. Okay.
Yeah.
All right. So just kind of final few thoughts, really. So what's the kind of the future of WebAssembly? What are you seeing, sort of, upcoming developments, trends that are coming down the line? Maybe areas, as you said, we've talked a little bit about certain limitations, stuff not developed as well in certain areas of WASM. What's kind of your take? What are you kind of seeing? That might be interesting and exciting coming down.
Yeah. I think, from the website, like, front end, I think WebAssembly is doing well, because that was the first use case, and it has a lot of time to develop. I would like to see. I mean, there is the component model that we talked about.
Mm.
Um, I would like to see more effort maybe into uh, something that get closer to POSIX. There is something called WASX, but it's not like still needs some work to be done
Mm-hmm.
on whatever we're trying to compile, and it's not there yet. It's not very popular as well, and I think what we need to do or to see is a serious effort into uh, like it shouldn't be WASI, right? WASI is one thing. We don't want to build new modules and new code the old way,
Mm.
right? When we build these WebAssembly modules, we want to build it in the WebAssembly way. But there
Right.
is a lot of code out there that could be ported, and we can't port it simply because the lack of compatibility. And if we have a serious effort that does like a good port of POSIX into WebAssembly, I
Mm-hmm.
think that could be a game changer.
Okay, so Samy, let's have some closing remarks. What's kind of your sort of closing remarks on WASM? We talked a little bit about the sort of your view of the future, and we kind of discussed a few things around that. But it's kind of what's the closing remarks around WASM?
Yeah, I think WASM is not here to fully replace containers or VMs. I mean, containers couldn't replace VMs either, but is not here to replace. But I think it's an amazing tool when it comes to trying to make software more portable. Go in, microservices. It's an amazing way to take in like a big monolithic
Mm.
application and trying to distribute that.
Yeah.
Um, it takes a lot of the burden out of the ops, because WebAssembly carries all of these security attributes, portability attributes, and
Sure.
so on. I mean, I touched a little bit on just reading what the WebAssembly module is important to
Yeah.
know what it needs. You can also read it to know what it's exporting as well.
Mm.
Um, and I think WebAssembly will be a game changer in the AI space as well,
Mm.
because it will allow AI to, especially AI agents, to execute code in a very secure way. And that could be done in both ways, right? Just like you could have code executed on the client side
Right.
and code executed on the backend side.
Right.
And that's what's amazing. Like that Python runtime could run on the browser as well. So highly sensitive code that for privacy reason needs to be on the web browser,
Mm.
it could execute there. So the agent just generates code, right? And that's I think that's where the future is going. I think WebAssembly will be a game changer. AI will be able to write WebAssembly modules,
Mm.
and we will be able to execute them in a safe, secure way.
Mm.
Less scary than some other regular code. And yeah, I think that's really where it's heading.
Cool. Okay. Yeah. So it's kind of we use WASM to build the AI platform, and then we ask the AI platform to write WASM code for us. So it's a kind of
Yeah,
a
yeah. I mean,
circular.
yeah. Maybe even getting to the point where you will rewrite its own code and modules in WebAssembly,
Rewrite
and
itself and improve itself. Yeah.
just
Yeah.
yeah,
Yeah.
yeah, yeah. Just
Exactly.
change these modules, like swap the old one with the new one.
Yeah. 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 Cool. All right.
And
So I mean, certainly it's a sort of a potential paradigm sort of shift. We talked about a new sort of smaller unit of computing, which is fantastic because that obviously optimizes and saves on resources and things like that. Yeah, so that's fantastic. So really appreciate you, Samy, coming on and doing this talk. It's been an eye opener for me. I've learned so much as usual. I always learn from all my guests, so really appreciate you really doing that. I think it's been great that we've kind of explored a lot of that space, and we're sort of excited, as we said, about the the future developments of it as well. I'm really certainly interested in seeing how it can kind of become more quote unquote mainstream. I think that'll be really cool. Yeah, and maybe we can revisit again and do some more talks and do some demos and whatever in the future. I think that'll be quite cool around sort of the WebAssembly space. So all the stuff that we've talked about and then some, I'll try and include all of that in the description of the video, all the details where to get hold of Samy and some of the stuff that he gets up to with Taubyte and everything else, which is his organization. All that stuff will be in the description of the video, so check that out. The other thing I wanted to kind of ask was, are you guys doing anything with WebAssembly? So kind of, just putting out to the viewers out there. Is this something that you're kind of investigating or maybe playing with in some, in sort of test environments and things like that? What's your opinion on all the stuff that we've discussed today? And what do you think the kind of some of the areas will be that, where WebAssembly can be used, and whether we actually manage to cover those today? I'm sure we kind of try to cover as much as we can, but yeah, do let me know. That would be really interesting. I'd certainly love to hear that. So drop us a comment on that. I hope you've enjoyed this talk. Please support the channel in all the usual ways, and we'll see you next time. Thank you for watching. Please don't forget to subscribe to the channel to support me. You may also want to check out some of the other videos on this channel. Bye for now.